Now that we've covered how to set up the solubility product equation, we're going to learn how to do some practice problems. And so this is solubility practice problems, and these are some easier problems. So if you'll turn in your notebook to Interactive Notebook page 14, you should see a worksheet that looks like this. It has 4 problems on one side, and it has 8 problems on the other. In this video, we're going to be looking at the side that says solubility product worksheet, and we're going to be looking at the problems. We're actually going to do numbers 3, 2, and 1 in that order, 3, 2, and 1. So let's start with looking at question number 3. All right, and I have it written out here. A2B has a concentration of 4.35 times 10 to the negative 4 molar. What is the solubility product constant? Okay, so what we're going to be doing is we're going to be solving for and using the Ksp equation. So the first thing that we have to do is we have to write our Ksp equation. If you're not sure how to write a Ksp equation, then you need to go back and look at the first video that's posted in here and how to set up a Ksp equation. All right, so Ksp, well, I have A2B, and this is just a fictional compound, but I have to think about what it would break into. Well, I know that A2B would break into 2 A's and 1b. And so it's going to help me write my equation. So I know that I have to take the form of ax to the a, bx to the b when I write these. So 2a plus 1b, that would be 2a2 times 1b to the 1, which would just be b. And I know that for each element in my compound, I'm going to replace it with x. So I would have 2x to the 2 times the concentration of x. Now when I simplify these, 2 to the second power is 4, and then that's x to the second, so it would be 4x squared times x, which is 4x to the third. So know that my Ksp formula is going to be 4x to the third. And now I have to figure out what side am I going to plug my numbers into. Okay, well it tells me that I have a concentration of 4.35 times 10 to the negative 4. Concentration is always measured in brackets, and that's going to be my x. So I'm going to plug 4.35 into x. The other thing that I can know is that I'm looking for the solubility product constant. I'm looking for Ksp, so I'm going to be solving for Ksp. So to solve for Ksp, I'm going to plug into x. So I'll do that over here. So I have my Ksp is going to equal 4 times my concentration, 4.35 times 10 to the negative 4th, and then that's going to be to the third power. So now I just need to solve this. Okay, well I have to remember my rules for PEMDAS, and I know that I'm going to have to deal with the exponent before I deal with the multiplying number. Okay, so what I'm going to do is I'm basically taking 4.35 times 10 to the negative 4, and I'm doing that 3 times. And so I'm going to have to distribute this exponent in. Okay, well when I distribute the exponent in, it's going to mean that I have 4.35 to the third power. It's going to take this to the third power, but it's really going to just multiply here. So I have 4.35 to the third power. So 4.35 times 4.35 times 4.35, did that 3 times, and I'm going to get 82.31, so it's going to be 4 times 82.31. So I've dealt with this because I did it to the third power, and now I'm going to just multiply my exponents here. Times 10 to the negative 12. So let me just kind of go over what I've done by plugging in my concentration for x. I have 4.35 times 10 to the negative 4th, but I knew that according to my rules of PEMDAS, I was going to have to do that 3 times. So 4.35 to the third power was 82.31, and then I just multiply my exponent, so times 10 to the negative 12. Okay, so I have 82.31, and I'm going to multiply that by 4 times 4 gives me 329.3 times 10 to the negative 12 power. Okay, well I know that this is not in the standard format. My number is too large because it needs to be between 1 and 10, so when I move it back 2 times, I'm going to have to add 2 to my exponent. So I get 3.3, I'm just going to round that, 3.3 times 10 to the negative 10 as my value for Ksp. Okay, so let's kind of look at what I've done there and see whether or not that is going to make sense to you. Okay, so let's go over it one more time. So I've written my equation, 4x to the third. I plugged in 4.35 in for x. I did 4.35 3 times, multiplied it by itself 3 times. I added my exponents, Then I multiplied the 4 in. Remember, I just multiplied my numbers, so 4 times 82.31 gave me 329.3. That number was too large, so I had to move my decimal forward 2 places, which means I had to add 2 to my power, and I get Ksp of 3.3. Now I knew that I was going to plug in for x and solve for Ksp because it gave me the concentration, which is going to be x, and it asked me for the Ksp. Well, what if it does something different? Okay, let's look at number 2 and see what happens when that occurs. It says, what is the concentration? So it's looking for x. What is the concentration of a saturated lead chloride solution if the Ksp is 1.17 times 10 to the negative 5? So they've given me Ksp. Well, I'm going to still do the same thing I've done before. I'm going to set up my Ksp equation. Ksp equals, okay, lead chloride. Well, I know that lead typically is Pb plus 2. So Pb plus 2, chloride is Cl minus 1, so I know that it's going to be PbCl2 in order to satisfy the charges. And it gave me a hint in that on the worksheet. It told me that it was going to be PbCl2. Okay, so PbCl2, I'm going to have to break that into its Ksp parts. Well, that means I'm going to have 1 Pb, but I'm going to have 2 Cl, so I know that it's 2 on the inside, Cl, 2 on the outside. I plug x in for each of those, so it's going to be x, and then it's going to be 2x squared, which gives me, when I do 2 times 2 and then x squared plus the x gives me 4x cubed. Okay, so that's going to be my Ksp. Now I need to plug in my Ksp because I am now solving for x. I need to solve for x. Okay, so Ksp is 1.17, so I'm going to plug that in here for Ksp. So 1.17 times 10 to the negative 5 equals 4x to the third. And so now I'm going to be solving for x. I've got to get x by itself. And in order to do that, my first step is going to be to divide by 4. So I'm going to divide both sides by 4. And so I will have 1.17 times 10 to the negative 5th divided by 4. So 1.17 times 10 to the negative 5th. And then I'm going to divide that by 4. And when I type that into my calculator, I get 2.93 times 10 to the 6. So I'll write that down. So I had 2.93 times 10 to the negative 6 equals x to the third, because I divided by 4. And now in order to get x by itself, I'm going to have to take the cube root of both sides. So I take the cube root of this side so they cancel, and I take the cube root of this side. Okay, so in order to take the cube root, there's a couple of ways that I can do this. I can either type in, if you know how to type this into your calculator, 2.93 times 10 to the negative 6, and I can take the cube root of that. I have a function key for that, and I get 1.43 times 10 to the negative 2, which is the correct answer. X equals 1.43 times 10 to the negative 2, my concentration. I can do it that way, or I can do it the long way. And to do it the long way, I'm going to split it into 2 parts. So I'm going to first just look at this, 2.93, and I'm going to take the cube root of 2.93. So 2.93, and I'm going to take the cube root of that, and I get 1.43. So I'll write that down over here to the side, just kind of as a practice. So I took the cube root of 2.93, and that gave me 1.43. And now I'm going to take the cube root of 10 to the negative 6. Well, I know that since these are powers, I'm going to divide them. So 6 divided by 3 is 10 to the 2 times 10 to the negative 2. Negative 6 divided by 3 is 10 to the negative 2. And so I get 1.43 times 10 to the negative 2. So it doesn't matter to me whether you enter it into your calculator, whether you do it into the 2 pieces, but that's how we get 1.43 times 10 to the negative 2. Now I knew in this one I was going to plug in for x because it asked me for the concentration, which was going to be x, and it gave me the Ksp. So I was going to plug Ksp of 1.17 into the Ksp spot, and I was going to find or solve for x, which is different than my first problem here because in this one I was solving for Ksp. Alright, so let's look at problem number 1, the last problem on our page. It says, what is the concentration of a saturated silver 1 acetate solution if the Ksp is 1.94 times 10 to the negative 3? Okay, so the first thing I have to ask myself is, well, what am I looking for? Well, I'm looking for concentration. So that means that I'm going to be solving again for x because they have given me the Ksp. Okay, so silver 1 acetate. Well, I happen to know that silver 1 acetate is going to break into one part. So silver Ksp equals silver, which is Ag, and then acetate, which is C2H3O2. And that breaks into 1 and 1. So that's going to be x times x, or x squared. So my Ksp is going to equal x squared. I'm going to plug my value in for Ksp. So I'm going to say 1.94 times 10 to the negative 3 equals x squared, and I'm going to solve for x. Well, how do I solve for x? I have to take the square root of each side. So again, remember this is a square root, so there's a 2 here. I can either type in 1.94 times 10 to the negative 3 and take the square root of that, which gives me 4.4 times 10 to the negative 2, because I go back 2 places, which is my answer. X equals 4.4 times 10 to the negative 2.